Hello, welcome to Unit 8 of Simple Harmonic Motion, and today we will be applying the conservation of total mechanical energy to solve problems involving springs, and we will be examining the connection between velocity and displacement for mass spring systems. So to first do this, we need to know the total conservation of energy equation, which I have written out here, which is mechanical energy is equivalent to the gravitational potential energy plus the spring potential energy plus kinetic energy. This can be broken down into mass times gravity times height plus 1/2 the spring constant times the displacement squared plus 1/2 the mass times the velocity squared. So now that we know that, we can do a problem involving springs. So we have a problem where it says a spring that has a mass attached to the end of it starts off at 0 meters and is stretched to 1.7 meters. So from that, we have our x initial, which is 0 meters, and our x final, which is 1.7 meters. Our mass is given, which says that is 0.55 kilograms, which is equivalent to 550 grams. That is the SI unit. And it is said it is traveling at a velocity of 1.9 meters per second. And to do this, we can use the spring constant that's given, which was 270 newtons per meters. So now that we have all that, we can go ahead and solve our problem. Since there is no height in this problem, our height is 0, and therefore the gravitational potential energy would be 0, so we just can omit that. So we can get started and plug in. So 1/2 270, which is the spring constant, times the displacement squared, and we'll use 1.7 since that's the final. And we will add 1/2 the mass, which is 550, times the velocity squared, which is 1.9. So, since we have that, we can get our calculator and plug in our numbers. So we'll do 1.7 squared, multiply that by 270, and we'll multiply that by then 0.5, and we get 390.15 for this side. And then we will be adding the other half of the equation, which is the velocity squared times the mass times 0.5. And we get the other half is 992.75. So when you add that, you will get the final mechanical energy, and we get it is 1,382.9, and that is in units of joules, and that is the mechanical energy conserved. So there you have it. Thanks for watching.